everyone, welcome back. Okay, so today we're going to talk about linear law and non-linear relation. Okay, so how is linear law and non-linear equation being applied? So as I discussed in our previous episode, you notice that there is some 1 over x, 1 over y, so you may wonder how is it applied and all that. So if you can see this equation here, so this is y equals to pqx. Surprisingly, how are we going to change this to linear form? That is where this is applied. So usually you use logarithm because you want to separate them out, and then you'll actually form a nice equation here. This is known as the mx, and this is your y-intercept c, and you just have to rearrange them and find it accordingly. So you may wonder, teacher, how do we do logarithm and all that? How do we do this? This is, you need to recap again about logarithm, and you can revisit my previous playlist where we talk about this in depth. Okay, so for the sake of understanding, let me just tell you what formula is being applied here. Is the part where, okay, if you have a and b, okay, you introduce a log a and b, you'll get an equation where it's just, you can separate out the a and b with log a plus log b. So for this case, they use base 10, hence all these are in base 10. So that is how is this being applied. So if there's b here with the power of x, so the power x follows b. And then if you remember, log base 10b with power of x, the x can go down, where you can actually get x log 10b. So this is two different applications to modify them. So you need to have a very strong basis in logarithm to apply for this and get the equation out. Now, once you get the equation out, so this is where this is getting quite stressful. So let's have a look. How do you plot a graph? How do you get that graph? Now, if you look in depth here, okay, they gave you an equation. Okay, so if you can see the equation here, first and foremost, convert them to y equals to mx plus c. So if you notice here, they usually, the strategy here is to make the y as the subject, okay, first, and try to dump everything to the other side and make either one of the values to x or y or something like that. So the clue here, you'll be wondering, teacher, how am I supposed to modify to what the question wants? That's the clue. Have a look at what they want you to plot. So if you notice here, they want you to plot y over x versus an x graph. So y over x and x. So you have to look at your equation back again. Okay, now we have the y. The y here is all alone. Let's just divide this whole thing with x first. See what happens. So, but in this question here, they divided with 3x. So they just want to eliminate the 3 one shot. So it's up to you. And then you notice you get y over x, and then the x is all alone. Okay, the x is all alone here. Hence, we got what we want. Now it's just rearranging it, and you can label this as capital Y, and you can label this as capital X, and then you are done. So now immediately you know your gradient is always with the x value here, p over 3, and then your y-intercept is q over 3, as per usual. Just do that, and then you are done, you're smooth sailing. Now, when you got these equations here, okay, y is, capital Y is here, this is capital Y, right? And this is capital X. Okay, so y over x, this is being modified. So what do you do with the original plotting here? Very simple, you recalculate them for y over x, but fortunately for this question, xt stays the same. So you can keep the x values, but correspondingly, what is the y over x value? So you have to calculate all this one that I'm circling here. Once you got this, plot it accordingly to what scale does the question want you to do. So like now, for an instance, the y-axis is using 1 cm to, sorry, the x-axis is using 1 cm to 2 units and 1 cm to 5 units for the y-axis or a capital Y. Okay, then you just calculate the best fit line and you get the answer. And you notice again, as I said, usually only the deviation is 1 to 2 points, maximum 3. Do not go more than that because it will never occur in your level of questions. But for further up, like foundation students and degree students, I believe you will see that. Hence, usually they'll ask you to use certain softwares to calculate them, but that's another day for another topic. Okay, so in our next class, we will learn where is this understanding being applied. So please stay tuned, and till then, stay safe. Goodbye.